Alright, now we're moving on to Chapter 7. This is Section 7.1, and this is Part 1 of 7.1, Simplifying and Multiplying Rational Expressions. If we're going to be simplifying rational expressions, we need to first know what a rational expression is. A rational expression is defined as the quotient of two polynomials. Remember, quotient means to divide. You really want to think fraction here. Here's some examples of a rational expression. X squared over 4x plus 1 is an example. You could have 2x plus 3 over x cubed minus 9. Notice that we have sort of fraction bars here. Those are rational expressions. They really do look very similar to a fraction. Alright, now that we know what a rational expression is, let's talk about writing them in lowest terms, or just simplifying them. The biggest thing to remember here is to factor. You're really going to need to use your factoring skills to simplify here. So factor it, factor everything. Factor the numerator and the denominator. Remember, the numerator is that stuff on top, and the denominator is that stuff on the bottom. Factor both of those, and then cancel top to bottom any factors that are alike. Let's look at an example here. X plus 5 over x squared minus 25. Alright, let's factor. Let's look at the top here. X plus 5. I don't think we can factor that anymore. So we'll leave it as it is. Look at the denominator. Look at the bottom here. X squared minus 25. Well, x squared is of course squared, and 25 is 5 squared. We have a subtraction here, so this is a difference of two squares. So remember, we factor those with two parentheses, one with a plus, one with a minus. Take the square root of the first term, so we're going to have an x. And the square root of the second term, square root of 25, is 5. Remember, 5 times 5 equals 25. Now we need to cancel. We have an x plus 5 on top and x plus 5 on bottom. They are alike, so they cancel. Now remember, when you cancel and it looks like you have nothing left on top, you're still left with a 1. So even though the x plus 5 goes away, there's still a 1 there. We cancel the x plus 5 on bottom, so it goes away. And we're just left with x minus 5. 1 over x minus 5. Alright, multiplying rational expressions. Now to multiply, we're really going to have to simplify as well. So the first step always in these rational expressions, when you're simplifying, multiplying, dividing, factor, factor, factor. Factor the numerator, remember that's the top, and factor the denominator of both expressions. Okay, and then we're going to cancel again, just like we did with the simplifying. Cancel top to bottom, and this time we can cancel diagonally any factors that are alike. When we get through canceling, we'll combine all that's left into one expression. It should still probably look like a fraction at this point. Sometimes we cancel and it doesn't look like a fraction anymore, but most of the time it will. Okay, here's our multiplying example. First we have x squared minus 2x minus 35 over 3x cubed minus 2x squared times 9x cubed minus 4x over 7x minus 49. Now remember, when we're factoring, the first thing we always want to look for is the greatest common factor. Plus, on these, I want to look for my easy ones. This 7x minus 49 looks like a pretty easy one to factor, so I'm going to start with that one. 7x minus 49. 7 and 49 have a 7 in common, so I'm going to take out a 7. If I take a 7 out of 7x, that leaves me with x. Bring the minus. If I take a 7 out of 49, that leaves me with 7. Alright, So that one's done. Let's look for another easy one. With this one, I see an x squared in common in both terms, so let's try that. Take out an x squared. If I take an x squared out of 3x cubed, 3 is going to stay. And if you take the x squared out of x cubed, that's going to leave you with 1x. Take x squared out of 2x squared. The x squareds are going to cancel, and I'm left with just a 2. Okay. Alright, let's move on. Let's try this one. There's an x in common, so I'm going to take the x out. 9x cubed minus 4x have an x in common. So I take an x out of 9x cubed. The 9 is going to stay, of course. 1x out of x cubed is going to be x squared. Bring down the subtraction. Take an x out of 4x. 4 is going to stay and the x is going to cancel. Okay. Now, here's the trinomial. We don't really like doing these most of the time, but the good thing here is sometimes when you're doing these, you can use the easier ones to sort of give you a clue of what might work. So we have to figure out two numbers that multiply to give me a negative 35 and add to give me a negative 2. And I'm going to have x here. I know that 5 and 7 multiply to give me 35, so if I make one of those negative, I'll get a negative 35. Well, look here. I have an x minus 7. So let me try that. What if I try a negative 7 and a positive 5? Positive 5 times a negative 7 is a negative 35. Positive 5 plus a negative 7 is a negative 2. We can FOIL this out and check it, of course. X times x is x squared. X times negative 7 is negative 7x. Plus 5 times x is 5x. So we have negative 2x. And then 5 times negative 7 is negative 35. Already I see something that will cancel. You can cancel as you go. You don't have to wait till the end. Here's an x minus 7. Here's an x minus 7, so they will cancel. So let's rewrite that with our canceled factors gone. We have x plus 5 over x squared, which is 3x minus 2, times x times 9x squared minus 4 over 7. Now, do I see anything else that will cancel? Well, yes. I have an x and an x squared that'll cancel. This x will go away. It'll cancel with this x squared and leave me with 1x. So now I have x plus 5 over just x times 3x minus 2 times 9x squared minus 4 over 7. Let's see if we're done. Do we see anything else to cancel? No. Do we see anything else to factor? Are we completely factored here? X plus 5 looks pretty simple. X is pretty simple. 3x minus 2. Can't get much simpler than 7. What about this 9x squared minus 4? Well, I see a subtraction sign here. 4 is 2 squared. 9 is 3 squared, and of course x squared is x times x, which is x squared. So I actually have a difference of 2 squares here. So let me factor again. Okay, difference of 2 squares. Remember, one's a positive, one's a negative. Take the square root of the first term. The square root of 9 is 3. Square root of x squared is x. Take the square root of the last term. Square root of 4 is 2. So we have 3x plus 2 times 3x minus 2. We have something else that would cancel now. The 3x squared minus 2's cancel. I think that's going to wrap everything up. Let's write everything together as one term, x plus 5 times 3x plus 2 over x times 7. I'm going to write that as 7x.